Alright, in this video, I'm going to show you guys a very beautiful proof of the angle sum formula for sine and cosine. And I know this proof does not work for all the angles, but as I said, it's a very nice proof, so you should definitely take a look. Here we go. For a review, if we have a right triangle, let's call this angle theta, then we know sine theta is just the opposite over hypotenuse. Multiplying both sides by the hypotenuse, the opposite side is just the sine of whatever the angle is times the hypotenuse. Cosine theta would be adjacent over hypotenuse, and that means adjacent is just cosine theta times hypotenuse. Now, the proof depends on a construction of a rectangle, and this is how it goes. Firstly, let's start with just this side of the rectangle, and then I'm going to create an angle, let's say this much, and we'll call that alpha. And then I am going to just kind of connect it like this, okay? And then from here, I'm going to create another angle, let's say from here to here, and I will call this angle beta. Now, because we're doing construction, so right here, I want to make sure it's long enough so that this and that, if I extend the top right here, they will touch each other. And then I would like to create a 90-degree angle right here. So this right here, by construction, it's going to be 90 degrees. And then I want to do it in a way that, so if I go from this point, if I extend it, I will connect it to here. And then I will just finish the rectangle, like this. Okay, it's supposed to be touching each other right here, but yeah. Anyways, because it's a construction, we can decide the length that we want. This is the hypotenuse of the right triangle inside. I will say that's equal to 1. And then you see that we have like all these 4 right angles because, as I said, we are creating a rectangle. This is 1. Now, this is why we refuted that earlier. This would be the adjacent of the red triangle. It's just going to be cosine of beta times the hypotenuse, right? Adjacent is the cosine of the angle times the hypotenuse. Times 1 doesn't matter. And then this right here will just be the sine version. So it's sine of beta. Cool. Now we just have to finish the rest of the sides. Have a look right here on this right triangle. We have alpha. This is the adjacent. We need cosine of the angle, cosine of alpha, and multiply by the hypotenuse. The hypotenuse is that, which is cosine beta. For the opposite, then we just have to do sine of this angle times the hypotenuse. Cool. Now we are done with that right triangle. Now let's focus on this tiny one right here. Firstly, notice that this right here is angle alpha. That's 90 degrees. So that means this angle would be 90 degrees minus alpha. Well, that's also 90 degrees. In order to add up a straight angle, this angle has to be alpha, right? 90 plus 90 is 180 already, minus alpha plus alpha, 180 degrees. So we're going to do the same thing, but with the blue triangle here. So this would be the adjacent. I will have to do cosine of this angle, so that's cosine of alpha, times the hypotenuse, which is sine beta. And then as of the opposite, we will have to do sine of the angle alpha times the hypotenuse, which is this one right here, right? Sine beta. And seriously, we are pretty much done. Why? Because now you see, this angle is precisely alpha plus beta. These two sides have to be parallel because we're on a right rectangle. We have this line, like this. So that means this angle must be equal to this plus that. Alternative interior angles of cut by the transversal. So now, we are looking at this right triangle. With this angle, the opposite must be sine of that angle. And for this adjacent, it's just going to be cosine of that angle. And ladies and gentlemen, here we go. From here to here is sine of alpha plus beta. But if you look here the other side, it must be this plus the blue portion, which is that. So there you have it. We get sine alpha times cosine beta plus cosine alpha times sine beta. Now for cosine of alpha plus beta, since it's only this much, well, it must be all the way from here to here, which is that, minus the blue portion, which is this. So that's why when we have the angle sum for cosine, in the middle it's actually a subtraction. That cosine alpha cosine beta minus sine alpha sine beta. And as I mentioned in the beginning of the video, unfortunately this proof does not work for if you have an angle bigger than like 90 degrees or 180 degrees. But as I said, because alpha and beta, they have to be inside of a rectangle like this. But as I said, I think this is a very, very beautiful proof. In fact, this is the remake from a proof that I did many years ago. If you want to see the old video, the link will be in the description.